Hello everyone, hello lovely students, welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So we have got these two questions for today's session. And before we get into solving these questions, I would like to specify that this video is in continuation of my past video that I have made on application of Wavy curve in funding domain. Alright, so let's solve the first one. The first question we have f of x is equals to square root of x minus 3 into x plus 1 upon x minus 2. Now, as you all know, whenever we have a square root function, that means some expression is written inside the square root sign. Then if we want to define or if we want to find the domain for that type of function, we have to make sure that whatever is written inside the square root sign, it has to be either positive or equals to 0. So this structure is very similar to square root of, we say, something. Now something can be an expression, just like here we have an expression x minus 3 into x plus 1 upon x minus 2. So in order to define this type of functional expression, we have to make sure that something is greater than or equals to 0. So in this situation, our something is this expression. Alright, now this expression is very similar to case 1 of wavy curve, and to some of the new students who are watching this video session for the first time, it might sound a little strange. So I request all my new students to watch my previous video so that you may get a better clarity of what I have taught about wavy curve. Let's solve this inequality using wavy curve. So this expression actually belongs to case 1. In wavy curve, I have taught in my previous video that there are two cases, case 1 and case 2. So this structure belongs to case 1, and for drawing wavy curve, we'll first find out the critical points by equating all the linear factors to 0. So we'll find the critical points by equating the linear factors to 0, and we have minus 1, then we have 2 and 3. So the critical points minus 1 and 3, they correspond to the linear factors of numerator, and the critical point 2 corresponds to the linear factor of denominator. Now we draw the number line and we'll try to arrange the critical points in ascending order. So we mark -1, then we mark 2, and then we mark 3. And in my past video on wavy curve, I have taught that for those critical points that we get corresponding to the numerator, we mark them using a filled circle. You can see here we have marked the critical points -1 and 3 using a filled circle, because these critical points are corresponding to the linear factors of numerator, and the critical point that we have got corresponding to the denominator factor, I have marked it using an open circle. Now, because this expression belongs to case 1 of the wavy curve, we start drawing the curve from the right side of the rightmost critical point and above the number line. Okay, and reaching 3, we decide to change the sign or not to change the sign depending on the power of the linear factor. So the power of the linear factor x minus 3 is 1, which is odd. So when we have an odd power, we change the sign from positive to negative. And again, we have to decide whether to change the sign or not to change the sign. So the power of the linear factor corresponding to x minus 2 is again odd. Actually, all the linear factors have odd power, because when the power for a mathematical quantity is not written, by default it is taken as 1. So we change the sign alternately, positive, negative, positive, and then again negative. So what message is this wavy curve conveying us? This the message is like this number line is running from -infinity to positive infinity. So the -infinity to -1 and 2 to 3, the expression achieves negative value because the wavy curve is below the number line, and the negative sign is a way to represent that the expression is negative in this interval or for these values of x. And for -1 to 2 or from 3 to positive infinity, because the wavy curve is above the number line, this expression we're talking about the left hand side expression. Okay, let's say E of x. We have named it E of x. So it is positive in this interval. And now we want those values of the variable x for which this expression is either greater than 0, which means positive, or equals to 0. So we should take the interval -1 to 2 union 3 to positive infinity. But we want 0 as well because we have equality sign, so this expression can achieve 0 value as well. So for 0, we can take -1 and 3. So -1 and 3 is also possible. So for that purpose, this open, we have to make it close by using a square bracket. And you all must be knowing this. 2 cannot be made close because 2 is present in the denominator x minus 2. So if you put 2 in the expression, it will become undefined because the denominator will be 0. So this is the final domain for this question. Hope you understand. Now let's solve the second question. The second question, we have fx is equals to square root of 4x minus x square, and again we have to find the domain. Now we have this a square root function. So whenever we come across a square root function, we have to make sure that the expression which is written inside the square root sign, it has to be either positive or 0 if we want the function expression to be defined. So let's do that. So 4x minus x square must be greater than or equals to 0 if we want fx to be defined, and the coefficient of x square is negative. So whenever we come across quadratic inequalities, it is advisable to make the coefficient of x square positive. So to make it positive, we can multiply this inequality by a -1, and when we do that, the sign of inequality will change. So we get x square minus 4x less than or equals to 0. Now we factorize this. We take x common, we are left with x into x minus 4, and this x can be written as x minus 0 into x minus 4. So now this structure reminds us of wavy curve, and it actually belongs to case 1 of the wavy curve that I have taught you in my previous video. And again, I request to all the new students who have come across this for the first time, you please watch my previous videos on wavy curve, and that will give you a better clarity and understanding of what we are actually talking about in this session. Alright, so we can solve this by the case 1. Actually, the case 1, we have to find the critical points first. So the critical points are 0 and 4. We mark them on the number line 0 and 4, and all the critical points are marked with a filled circle because they are corresponding to the linear factors in the numerator, and we don't have any linear factor in the denominator. This expression is not a rational expression actually, so because we don't have any denominator here. So we start drawing the curve from the right side of the rightmost critical point and above the number line that I have taught in my previous video, and we change the sign at 4 from positive to negative because the power of the power of the linear factor that corresponds to the critical point 4, x minus 4, is odd actually. So all the linear factors have odd power. So at all the critical point, we'll change the sign of the wavy curve, and this I have taught in my previous session. So we get this final curve, and the message which this curve is telling us that in the interval -infinity to 0, the curve is above the number line, and in the interval 4 to positive infinity, the curve is above the number line. So this expression achieves positive value in this interval, and in the interval 0 to 4, because the curve is below the number line, the negative sign shows that if you put any value of x from this interval, this expression will be negative, and we want negative or 0. So if we want negative or 0 for this expression, we must take the values of x from this interval 0 to 4. So 0 to 4, our expression, let's say this is E of x. So E of x is negative. E of x is negative, and we want 0 as well. So 0 and 4, we have E of x is equals to 0. Now we have to combine both of these solutions. So in order to include 0 in our solution, we can just make this round bracket as a square bracket, and this 4 also we have to include, and you all must be knowing this, that this closed interval we write in this way. Okay, so this is the final domain. That's all. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming videos. See you all my lovely friends in my next upcoming videos with more exciting and awesome questions. Till then, bye bye, stay safe and have a nice day.